Welcome back to the channel. In today's video, we are diving deep into some fundamental concepts in C programming. Structures, union, structure padding, and storage classes. These might sound a little intimidating at first, but I promise by the end of this video, you will understand them clearly and know when you to use them in your code. Okay, let's get started. First, let's talk about structure. What is structure? Structure is a collection of variables of different data types stored at different memory locations. Each member gets its own memory space. Collection is a Structure is a collection of variable of different data type to store at different memory location. Each member gets its own memory space. Okay, think of a structure like a way to create your own custom data type. Let's you group variable of different data types together under a single name. Mm, Imagine you are describing a book. Do you want to include the title, which is text, the number of pages an integer, and the price probably a decimal number? A structure lets you create a book type that holds all the information together. Okay. Why we need structure? Well, it helps you keep your code organized instead of having separate variables scattered throughout your code. You can group related data into a single, easily managed unit. This is especially useful when you are dealing with complex data like employee records, student information, or even game objects. In C, you define a structure using the struct keyword. Here, struct keyword followed by the name of your structure. I give the name as student and curly braces containing all the number of the data types. See, for example, I'll give the character name array of 20 is the size of character and integer as age and float as marks. Okay. I hope you understand the structure. How memory allocated for this structure? Here, for these types, how many bytes for integer? 4 bytes. Character, 1 byte. For three these data types, sum the three data types bytes. So these memories are allocated in for structure. Okay. Now move to union. Similar to structure, but all members share the same memory location in union. Union is also a user-defined data type like structure that holds different members but with a major difference. All the members of the union share the same memory location. It can hold a value of only one of its member type at a time. Why you need union? It saves space, particularly when you know you will only need one of several possible types of data at a given moment. For example, maybe you want to represent a value that could be either an integer or floating number, but never both at the same time. Instead of reserving memory for both, you can use union to share space. This is an example for union. For structure, here's the char, here's the integer, and here's the float. For union, here which is large. I assign the value as 20, so it's large. Here 20 byte allocated. Other two int and float are share with this memory. Okay, I hope you understand this clearly. In union, we use the union keyword to declare an access is similar to structure. But remember, when you change the value of a member, it overwrites the value of other member present earlier. Okay, now let's talk about structure padding. This is something that happens behind the scene, but it's good to know what's happening. Okay, what is structure padding? Structure padding refers to the empty space that compiler sometimes inserts between members within a structure. Compiler adds the empty byte or extra memory between the member of a structure. It's not something you directly write in your code, but it's done by your compiler to align your structure members correctly in the computer's memory. Why you need structure? Why do compilers do this? Computer processor read data most efficiently when it's aligned to specific memory address, like multiple of 4 bytes for example. The compiler adds padding to ensure each member starts at an address that makes access faster. It is like fitting all puzzle pieces together in the best way possible, even if you leave some empty space in between. For example, here for structure, I have array of A. Character is a 1 byte, okay, and integer is 4 byte. So other 3 bytes are allocated here and 1 bytes are allocated here. So it is an unaligned memory access. What is aligned and unaligned memory access? If the data address is divisible by number of bytes you read is aligned. If the data address is divisible by number of bytes you read is aligned. Unaligned means not divisible by number of bytes you read. For example, I take integer. Integer is 4 byte. I take a one number. Here I put a integer. Okay. For this I give a 1004. Or here I give 1000. Now see, 1000 is divisible by 4. Yes, 1000 is divisible by 4. So it is a aligned memory access. If 1001 is divisible by 4, no, 1001 is not divisible by 4. So it is unaligned memory access. So for this, how to align the data to get access easily? You don't generally need to worry about the technicalities, but remember that structure size might not be simple sum of all numbers size due to the padding mechanisms. Here's the padding works. How with the padding, um, first we have to put the character and leave the space. After we put the integer. So these extra spaces are padding. These extra spaces are padding. With how to avoid padding means we use pragma or we rearrange the data structures, rearrange the order, attribute packed using bits to avoid structure padding. Finally, we'll move to the storage class. Okay. Storage class are keywords that control the scope and lifetime of variable along with the location of a variable and default value. The basic idea is to control where a variable can be accessed from and how long that variable is present in memory. Understanding storage class is important for writing modular and well managed code. They ensure that variables are accessible only where they need to be and memory is efficiently utilized. We have few storage classes in C. What this means auto, register, static, and extern. Okay, here for a scope of auto is block within the block. Block scope means see here the curly braces. So it's a block. Within the block the variable is perform. Block here it's a lifetime is also block. Outer the block the variable does not exit and its memory is stack. It's stored in a stack memory and it's a value default value is garbage value. For register also a block scope, lifetime also a block and it's register in CPU. Its default value also a garbage value. Static block scope, its lifetime is throughout the program and it stores in data segment. It stores in data segments. Its default value is 0. For extern, it is global. It's a global scope and its lifetime also throughout the program. Extend stores in data segments and its values default value 0. Here, understand one thing in static. Static variable retains the value between function calls. Static variable retains the value between function calls. For example, uh, if we take a variable int a equal to 0 and then I increase the a means the loop through first take the 0 and add it in a value. Example rest value means add it in the rest and after that increment it does not change the value. It retains the previous value 1 and add it. What's the previous value? 2. Add it. For extern, to access global variable from another file. Extern is used to access the global variable from another file. So that's a quick run through of structures, union, padding and storage class in C. Structure and union help you to organize data. Structure padding ensures the efficient memory access behind the scenes and storage class gives you control over variable behavior. These are fundamental concepts that you will use over and over as you continue to learn C programming. If you found this video helpful, please like it, subscribe to the channel for more C programming tips, and leave the comment below if you have any questions. Thank you for watching and happy coding. I'll see you in the next video. Bye.